Hi everyone, my name is Peter Neubauer, and I wanted to give you a small introduction to Neo4j before I hand over to Corey at KeyLines and also touch some of the visualization. So let's just begin by just saying how is Neo4j different from others. So our core problem we are trying to solve is how to walk and traverse huge graphs, right? This is not a new theory. Graph theory has been around for a long time, but it is kind of hot right now, right? Everyone's talking graphs, and the graphs get bigger and bigger. Basically, they are the holy grail of business intelligence, because in a graph, the relationships between data points or nodes are equally important and equally easy to traverse, as opposed to, you know, in-table relationships, which are tuples, which are very easy to group together, and then joins in between tables, which are very, very hard to do. So how does that look in Neo4j? Neo4j is a graph database, which means it is a database. It's not an in-memory, you know, MATLAB or whatever thing. We're actually supporting real transactions, failover, clustering, you know, the whole shebang you would expect from a database. However, if you see relational databases and you're trying to do a graph or a network or a hierarchy of things, then you would probably end up with some kind of foo table and a bar table, and then if you want to hold relationships between these two with values on the relationships, then you would probably do a foo joins bar table, and then, you know, have a foo tuple that links via foo bar tuples to bar tuples. That could be like persons and pets and persons own pets and so on. So this is a very costly operation. Just to join foo and bar, you have to do two joins, which are basically index lookups. So a relational database doesn't give you a relationship. It just does give you the possibility to establish relationships once you make them join. In Neo4j, we are going a bit differently about the problem. What we say is, why not join them at what we call insert time? So when you talk about the data, you actually make these relationships that can be there explicit. So we have that, you know, foo node, then we have, you know, foo bar relationships to our bar nodes, and on these we can have properties in a key value fashion. Why would that matter? Well, in Neo4j, this is linked on storage. So basically what we're doing on storage is pointer chasing. When you want to traverse from the foo nodes to the bar nodes, then this is a constant time operation as long as you go along the relationships. And that means this does not touch the whole of the graph, which means performance is constant as the graph grows, and you are keeping that query what we call data local, right? So the core data model of Neo4j is what we call a property graph, which consists of nodes, relationships, and then properties on each key value. And as you saw, the animation was disappearing. The different colors basically mean labels. So you can label nodes in order to give them kind of tags that you can attach schemas and so on to, which we will cover later. Okay, cool. So what does that mean? If we have a normal graph, then in a relational database, this will not scale over a big graph, while in Neo4j, as I said before, this is constant. The query time of friends, for instance, or shortest path or path that exists is not dependent on the total size of the graph, right? So how do I query this? It looks like a very fuzzy concept to query a graph that has almost no schema. We came up with a ASCII doc-based declarative graph query language, which is very, very popular right now, and we tried to make it as SQL-like as possible. So this is a graph pattern that you look for instance, a is connected to B is connected to C, and A is connected to C also. The database will then fetch stuff that matches these patterns for you, right? How do we do this? We express it in ASCII doc. Round things are nodes, arrows are arrows, and then we have variables on these, right? Then we have the match clause that expresses these patterns, and return other clauses are almost like SQL. So it's kind of a good to recognize, right? So if I query our little example graph, we start somewhere, say with the node lookup at Andreas, and then we basically match our people nodes that are in 2 hops away from our friends of a friends nodes. We anchor that with n.name is Andreas, which will resolve to, for instance, an index lookup for all nodes. We actually combine the core network engine with index providers in order to make global lookup operations, which you need if you want to do, for instance, full text search, possible. That is not a very cheap operation in a connected property graph, so that's where we use indexes. And then you return the friend of a friend, here marked blue. So that's a very, very brief introduction to that. Neo4j is written in Java, so there's a number of embedded bindings on the JVM to Neo4j. However, as Cypher is becoming the prevalent and most popular choice to connect to Neo4j, and we have a very, very nice server, which I will show you. There's all sorts of bindings based on REST or other protocols to that server, so it's no problem to connect from .NET or from Erlang or so to Neo4j or for Node.js and PHP. So who's using this? When we first did this, we came from a content management background, having very complex things. So we thought about some verticals like web and finance and datacom and so on, and then some kind of use cases: social, master data management, network center data management, and geographic and spatial stuff. And yes, there are a number of customers using this. These are just customers that actually pay us money and are partners to Neo Technology. However, as it turns out, the space is much bigger. Basically, anywhere where you have deeply connected hierarchies, think of like product variants or folder hierarchies or so. In a relational database, every one of these, if you have a 15-level deep, folder nesting, then these are 15 joins if you want to fish out all the files that are nested under a root folder. Or if you have networks, as you get into bigger data, it makes sense to look at a graph database, especially at Neo4j, which implements, as I told you before, the constant time operations for relationships. So there's a lot of use cases. I just wanted, I can't tell you all the use cases, but I wanted to demo some of that things to you. So as we are talking about visualization, one of the things is, of course, just to install Neo. Let me just pull this up and make it a bit bigger. Hope you can see this. I just install Neo4j. Here we go, and then we say Neo4j start, which means we now have a Neo4j server running. So now we can access the REST API, which we can use to visualize things at localhost 7474/db/data. And we see there's a lot of information here that we can use. Especially what's interesting is the Cypher endpoint, where we can use queries. This is what the web interface is written upon. So if we go to our local browser, this is now connecting to our server. We can just insert some data by again, executing some cipher query. Here we have a create statement and so on. There's a lot of nodes being inserted. And we return, in the end, the matrix node. So let's put that into our editor, execute it, and we then have a node here, right? So if we then style it and say we want to have it a bit bigger and the caption should not be the ID but the title of this thing, then you see the matrix. Double click on it, we get basically a force-directed layout. We want to have the name of this as the, and we can see there's stuff going on here. So this is a force-directed layout, which is actually pulling its information from the server. If I look here, I can see in the network how things are going here. And you see here we have actually we're going to the query API and asking questions against the server. So this is pure REST. You can build your own visualizations, but of course, for instance, KeyLines is much more powerful than this D3 based document visualization. So when it comes to use cases, I could talk all night about customers that are implementing things. However, there's a nice community resource which is called Neo4j GraphGists. So if you go here and look at the GraphGist collection here, this is a wiki with a lot of people contributing use cases in different areas. For instance, say you know, Bombay railway routes. This is logistics. We go here, and what we get is a in-memory Neo4j database on Heroku that is executing these things. You see here queries, that is the setup, which are executed against that database with actual returns. And then you can visualize this in, for instance, here, again, a force-directed graph here. So also, if you have your own things that you want to visualize here, you see you can do these queries and get the actual returns back. So there's loads of examples here that you can look at. So I urge you to go to that wiki. For instance, here you have, you know, options trading a graph. How should I sell and buy things? And so, again, this is a simple force-directed layout where the labels of the nodes are painted differently, and it's a very standard thing. But yeah. So this is a very fast introduction to Neo4j. I will now, you know, let Corey concentrate on visualizing the more complex aspect of things. These are some generic visualizations, and I think KeyLine is much more powerful and anything that is existing in the community. So please stand by here.
Hi everybody, thanks for attending our webinar. I apologize for the bait and switch. I'm not actually Joe Perry. My name is Corey Lanum. Our company's founder and CEO was originally scheduled to do this webinar, and he had some last-minute travel obligations that came up. So I handle our U.S. business, and I'm going to be standing in for Joe today. Peter did a great job of talking about the benefits of not just Neo4j itself, but the benefits that are gained from thinking about your connected data in a graph format. And so where I'm going to pick up from that is to talk today about the value to be gained, not just from storing your application's data in graphs, but also presenting those graphs visually to your end users. And of course, I'm biased because I work for a visualization company, but I think that the ability to show an end user, an application's end user, their data in a graph can in many cases be more valuable than the actual method by which it's stored. So, and it's not always the case that presenting a visualization of the graph to your end users is an important feature of your application. So there are, as Peter mentioned, many different use cases of why using a graph database like Neo4j might be important. And some of them may not require that the end users have any idea what it is that you're doing or what the data looks like. For example, I've talked to a number of people who have built recommendation engines. And recommendations engines are very easy to build when you have a graph database because you know who, for example, has purchased various products and who they might be linked to that may also be interested in those products. Presenting those connections in a visualization to the end user is not necessarily something that the end user is going to care about. They want to know what it is that they should buy or what they might like, and how you got there is not important to them. But in many other cases where you're utilizing the power of thinking in a graph way and you're using a graph database, showing the end user the results of that so that they can understand, perhaps even manipulate the data that they're working with is incredibly important. So Joe founded Cambridge Intelligence in 2011 with the idea that, that the visualizing information in a graph can be as important or even more important than storing the data in a graph. And over the last 3 years, we've proven that concept has been important for many customers in a number of different industries. So today I'll be talking about a couple of different things. One is how to build interactive visualizations for your customers of the applications. And then along the way, I'll be showing the KeyLines toolkit and some of the features that we include. I don't intend for this to be a sales pitch. Of course, I would be delighted if everybody on this webinar were so excited by the material I present that you rush out to buy licenses of KeyLines. And I should mention that there are multiple avenues for you to manifest that excitement. We have both free evaluation licenses of KeyLines available. But if you're really excited by what you see, you could also work for us. We are hiring talented JavaScript engineers, and we would love to have a conversation with any of you about that. So let me open by introducing our KeyLines component. So the KeyLines was designed as an embeddable web-based graphic visualization and analytics component so that application builders can present their connected data to their end users in a completely customizable and interactive way using the latest HTML5 canvas technology. What I want to do is to take a second to contrast KeyLines, which is what I'm showing you, versus the Neo4j browser, which is what Peter showed you. They do look quite similar on the surface. However, they're designed, at least in my mind, for different purposes. So the Neo4j browser is designed for you, the data scientist or software engineer, or whoever it is that's building the data model and the application that you're working on. And it's a great tool, and it's one that even I use when building graph models in Neo4j for my customers. It helps you understand the model that you've created. It helps you make sure that the data that you've put into that model is organized correctly. The relationships are between the same two entities that you expect. But it's not designed for your end users. You're not going to have them pull up the Neo4j data visualizer to look at the data that you've put in the application. First of all, allowing them unfettered access to your data can have disastrous consequences. Oftentimes, you very much want to constrain what it is that they can look at and constrain what it is that they can edit. But also, you need much more control about what it is that you're showing. So you often will want to abstract out the technical detail about how this is stored and show your users a logical diagram of the data that you're storing. So for example, let's say you had a node that represented me and some of my connections. So if your application's end user is looking at a node that represents me and my connections, it's because they want to learn more about me. And so it would be confusing and irrelevant to show a user that I'm node, for example, 518612, and here's a list of all of the properties on my node. Instead, let's select the important elements, my name, my birthday, the fact that I live in Massachusetts, and present those to the end user. And then maybe have the additional properties displayed only when the user clicks or hovers over my node. So that's where KeyLines comes in. You've spent a lot of work coming up with a great graph data model to store your data. So KeyLines helps you create a great user interface experience so that your users benefit from all of that work that you've done. So I talked about KeyLines already, but KeyLines is a component that you build inside your application. It's not an off-the-shelf data browser by any means. If you were to buy a license for KeyLines or evaluate it, what you get is a JavaScript library alongside a Flash library so that we can support older browsers that has a comprehensive SDK that allows you to embed it in your application and control every facet of what you want to present to your users. And we'll show you some details about the customization capability that we have. But it is important to get the point across that KeyLines requires some different experience and JavaScript experience specifically to build KeyLines on top of your data source and to link it to the other components of your web-based application. So let's take a step back and talk about why we may want to present visualizations to our end users. You know, the old adage that a picture is worth 1,000 words, I'm sure has been used many, many times. But it really does make sense. If you're talking about connected data sets, looking at those connections, specifically in a graph format, for your end users is going to help highlight that. And the more that you can customize that user experience, the better. So let's talk about how KeyLine sits on top of Neo4j, and then I'm going to jump out and start showing you some actual examples where we've taken KeyLines, some sample Neo4j data, molded the two together, hosted it on a sample application that we built on the web, and I can show you some of the source code as well. So although we work very closely with Neo, and many of my customers are Neo4j customers as well, KeyLines itself is database agnostic, and the data can be brought into KeyLines from any source, including just generated automatically in memory or from a standard relational database. The way we work with Neo4j is that we use the REST interface that Peter talked about earlier. So KeyLines is sitting in memory running inside your browser, and you tell it when you want to obtain new data to visualize what the cipher query is to obtain that data from your KeyLines or from your Neo4j database. Neo4j will turn around and submit a JSON response back to your web page with all of that detail. And then there's a little bit of visual styling that you have to do to the data to tell KeyLines, okay, this is not just the data, but how do I want to present it? What node icon should I use? What color should I use for the links? Various other things like that, and I'll show you some examples of that. So it's a very straightforward process in how to bind KeyLines to your Neo4j database. The other thing that I want to discuss is when this might be beneficial. So who, at least currently, is using graph visualization as a core component of their application. And we've had success in a number of different industries. I'd say the first one that really got us started as a company was fraud. Not in committing fraud, of course, but in helping companies like finance, banks, and insurance companies uncover fraud in their data. If you think about fraudulent transactions, it is a transaction itself can be represented in a very graph-oriented way. It's a link between two entities who could be banks, they could be credit card users, they could be insurance claimants, things like that. And looking for patterns in those links visually, things that map the normal course of business versus ones that are aberrant and should be investigated further as potentially fraudulent. And our customers have had a lot of success using KeyLines to do that. Information technology is another area where I've been really surprised by the take-up of KeyLines and of doing graph visualization in general. If you think about a physical network, especially at a larger organization like a Fortune 500 company, they have a lot of interconnected things, applications that are hosted on servers that are connected via routers and switches, and all of those depend on various storage devices. And to be able to understand the impacts of various items in your network really helps. It really helps if you can present that information visually, allow your users to manipulate that data that they're looking at, issue complex queries. So before I go further, actually, let's take a look at an example where we were working with a large information technology department at an organization. So this is KeyLines, what you see here. And you'll see me switch back and forth between the slides and the browser some. And what we have is our customers sent us an example data set of all of their connected data in Neo4j. And when we first brought it into KeyLines to look at how it was all connected, it didn't really help much. I mean, I'll be completely honest. If we were looking at this and saw this sort of blob mess, you don't really gain a lot of intelligence about what it is that you're looking at here. So there we go. So we did a couple of interesting things with the customization capability with KeyLines to help our users understand and gain valuable intelligence out of this connected data set. So you can see as I zoom in here a little bit that we're looking at various typical type network things: services, hosts, servers, disk drives that are being used by those hosts, SAN units, and then also the business units that depend on the applications that are hosted on those servers. Everything's connected to everything else. You don't get a whole lot of pattern here, but we did a few interesting things. So what we captured the hover event. So that's one of the events that KeyLines can capture to say, okay, look upstream from whatever I'm hovering over and change the highlight color of those items. So if I'm interested in finding out, okay, who's depending on this virtual host? Well, I immediately see that it's the servers 9 and business function 7. This has all been anonymized so that I don't present any actual customer data. However, what we may also want to do is to look at not just the connections, but the effect of those connections. So we did something called impact analysis, and what that does is it will size the node. Let me run a new layout here. It will size the node in accordance with how many business functions are reliant on those particular devices, so that it becomes immediately apparent to the end user which are the highest risk items here that we're looking at. And then another thing that we did that we called focus mode was to be able to do some filtering on the chart to say, okay, now that we have all of this connected data, let's say we want to drill down and focus just on some specifics here. Let's look at server 13. So if I click on server 13 now, I'm taking everything that's not in the direct path of that server, that doesn't depend on it, and removing it from the chart. So you're looking at this in isolation now. And now some of the layouts that we have built into KeyLines can be really useful. So for example, I just ran the hierarchy layout, which organizes the data in a tree structure underneath the selected node so that we can see server 13 has the following hosts that run on it. Those hosts have the following services that run on it. And here are the business functions that depend on those services. So in a domain like IT, being able to parse through these complex connections and data sets is something that KeyLines is very good at. Government is where my experience is. So I've been doing graph analytics and graph visualization for about 15 years now, and got my start doing it in various intelligence agencies here in the US and in Canada. And to be fair, they are one of the areas where they started looking at graph technology and graph visualization much earlier than the private sector. And many of KeyLines' customers are out of that area, just due to the fact that that's where both I and the founder of the company have come from. Being able to look at linked data that not necessarily be physically linked, but maybe linked by virtue of family relationships, if you're uncovering gang activity in the inner city or looking at terrorist activity across the world or things like that. Something that intelligence agencies do and really need to understand what is the impact of an operation that I may take in a certain country, who is linked to the various affected parties. How might that spread out from where I'm aiming to accomplish whatever it is I'm aiming to accomplish. And then the final category there that we've just started to have some uptick in is oil and gas. And so I'm used to thinking of graphs and links between things as being these ethereal concepts. Somebody is somebody else's brother, or they have a business connection, or things like that. In oil and gas, it's more physical infrastructure. There's actually a real pipe connecting these two things, and there's not data flowing across it. There's actual material like oil. And so that's been an area where I don't have a lot of personal experience, but those that do have found a lot of benefit in using graph technology and graph visualization to help understand the connected items in their data set. So I want to talk about some of the customization capability that we have in KeyLines and how those customizations can be useful. So the aim of any visualization should be to convey information through visual properties. And what that means is that you have in your Neo4j database a large number of properties associated with both the nodes and the edges that you're looking at. Many of those may be something that you or users need to understand. Some of them may not. And each one of those can be bound to a visual property in the visualization. So using node icons is a very important thing. I'll show you some examples where we do that. So that if you're looking at a person, you're representing them not with a circle or a square with a color, but an actual person icon itself, sometimes even the image of the person. If you're being able to use color to indicate some sort of value, numeric value in your data. So as you see over here on the right, the deeper colors mean something substantial, and the user should know intuitively what that is based on the type of data that you're collecting. Node sizes is oftentimes something that you're also going to want to use to indicate the importance, because larger nodes are likely to stand out amongst the background when you're looking at this type of data. And then glyphs is another interesting thing that we've come up with as a way to take additional properties and expose those to your end users. So let me go to another example here, where we have it's a really trivial chart here, but it gives you some examples about how you might use some of those various properties that you can control. So for example, I talked about how you may want to use icons instead of shapes for your nodes to indicate this is a person, this is a car, this is an address, things like that. You may want to use the image of the person if that's data that you have access to. Makes it very obvious to the end user. And then we have, if you look at Big John here, this is what I was calling a glyph. So in this case, Big John is Canadian, and we're using the Canadian flag as basically an ornament on his icon to expose that property visually to the end user. So they don't have to look at a property page. They don't have to do anything specific around that by clicking on it or investigating a form to understand that. If that's a property that you think is going to be important to your end users, you can expose it right away. So obviously it doesn't have to be a flag, it could be anything. Oftentimes in our IT customers, they may want to use a warning flag or even an animated warning flag to indicate this is a node that requires your immediate attention. This server is down. Here's everybody who's affected by that. So those types of things can be controlled on the nodes. They can be bound to properties in your Neo4j database, or they can just be set outright to match the look and feel of the rest of your application. If we look at edges, there are certainly things, visual properties of the edges that may be useful to expose as well. Some of those are like color. For example, link color oftentimes our customers will use to indicate the type of relationship, so that two things linked with a green link may mean that there's, let's say it's people, it may mean a family relationship. Whereas two people linked with a blue link might have a business connection or something like that. I would recommend against using gradients of colors on the links, just because it becomes hard to distinguish between the two, whereas gradients can be effective on the nodes because you have more surface area to work with. The other example that, or other visual property of links that we can use is link width. And that shows us the strength of the relationship oftentimes. So two things that are more heavily connected can have a wider link between them. Two things that are weakly connected can have a thinner link between them, and that makes it obvious to the end users what they're looking at. So let me show you an example of where we've taken that into account. So this is a relatively famous data set. Basically, when the Enron organization collapsed in 2003 or 2004, the United States federal government investigated them and subpoenaed 1.5 million emails from the individuals within Enron. And it took that data set of who's talking to them, and the text of all of the emails and everything, and made it publicly available. Anybody can go and download all of those emails. So we did so, and we took a look and modeled it in Neo4j and took the results. Well, the people in Enron are nodes themselves, and the links between them indicate that these two people have communicated via email. As you can see, we've done links in both directions. So you can tell the difference between Kevin Presto emailing Rogers Herndon versus Rogers Herndon emailing Kevin Presto, for example. And here I've done some interesting things with the data model as well. So if the end users part of their workflow is to identify very quickly just who is this person talking to, I did a similar thing that I did with the data center example, where hovering over a node will highlight that person and who they're connected to. Another thing I did was I captured the click event, and clicking on a node will actually create another instance of keylines over here on the right. You can have as many instances of keylines on the same HTML page as you'd like, and they can communicate back and forth to remove it from the clutter of the rest of the chart and show it just in isolation. So that's what we've done here. But I was talking about the link width and how that can oftentimes convey very interesting information to your end users. So right now, all of the links are the same width. So we don't get the sense of whether these two people have communicated just once or on a regular basis over the course of the investigation. But if I turn the link widths on, you can see that now we have thick links representing heavy email correspondence and thinner links representing less. So, for example, Chris Germany has sent a large number of emails to Scott Goodell, but he has sent very few back in the other direction, something that's immediately visually apparent when you look at this data set. So I've been showing you as we go both how to create useful visualizations or useful visual parameters to assign to the nodes and edges that you present to your end users. And I've also been showing you a little bit about how we make our charts interactive. But I do want to talk about all of the various interactivity that KeyLine supports that I think is really useful. So the ability to issue queries and get back subsets of the data is, I think, something that's critical, absolutely critical for any production implementation of any sort of graph visualization engine. And the reason being is that very quickly the data volumes that you're working with become too much to manage in a single screen. So, and this is oftentimes when I'm working with customers who are new to graph technology and graph visualizations. The first thing they ask me to do is to let's just go get the data in my Neo4j database and throw it up on a KeyLines chart and see what it looks like. So this isn't even that big of a chart. This is 1,000 nodes and 1,000 links in a very tightly connected data set. So many things are then linked to many other things. And as you can see, this is pretty useless from a end user standpoint. There's not gaining any valuable insight into what's going on in this network or in this data by looking at this chart. And there's not much we can do around creative ways to lay it out or organize it that would make it much better. It's going to just be this big connected mess no matter what. So the ability to issue individual queries and bring back just the results of those queries is an important part of creating a useful visualization. So those of you who are currently using Neo4j will recognize this data set. In fact, I think it's the same one that Peter presented. And I'm doing a very similar thing to what we do in the browser. But what I'm showing you here is that we're actually creating under the hood the Cipher query that happens via a user interaction, submitting that up to the Neo4j REST interface, getting the results back, and then running the visual parameters on that data. So if I double click on the matrix movie here, here's my Cipher query. It says go off. I just clicked on node 89. Go off and find all of the people who have the relationship types of accent to the movie I clicked on, and return both the actors, the movie, and the person and the relationship to the chart. So we get all of that data back, and then in our JavaScript we do the visual manipulation to say let's use the blue icons if it's a male actor, the pink icons if it's a female. I want my links to be blue. I want the label on the links to be accent, and various things like that. But let's continue exploring through the data set from there. So perhaps now I'm interested in Carrie Ann Moss, so I double click on her. KeyLines goes off, issues a new Cipher query, similar to the previous one, but now it's saying go find the movies that this actor was in and bring those onto the chart. And so now we have various additional movies that Carrie Ann Moss has acted in. I can keep going. So if I double click on the matrix reloaded now, I'll run a new layout. You can see that I got some new actors who were added to the chart because they weren't previously there. But because the node IDs matched some actors that were already on the chart, KeyLines recognized that, merged the incoming data to the nodes that were already there and just added the links to them. So now we can see immediately who the 5 or so people are that were in both the matrix and the matrix reloaded, for example. And then as you expand further and further, the layouts become more and more interesting and more useful for organizing the data. So things like the structural layout, which organizes groups based on connected patterns that it sees in the data, can become very useful. So I covered query and layout there, and you saw the animation. I think animation sometimes has a bad reputation as just being eye candy, but in many cases I do think it's very useful, because especially when you're reorganizing data or you're bringing new data onto the surface that your customers or that your user is using to visualize, animating can help them understand what's happening and not lose their place with the items that they're focused on. Explore is what I basically just showed you. Instead of presenting all of the data to your end user at once, we may want to go off incrementally and get new data and bring that new data on as the user is interested in it. That way they can sort of guide the workflow of what it is that they're interested in. And then the combine and filter, which is the bottom category there, this is a very important piece in that not every data element needs to be drawn on the chart at once. We may want to not have a one-to-one correspondence between our Neo4j data elements and what we show on the chart. So one more example here. This is an open source data set of terrorists and connected intercepted communications between terrorists. And we've used the flag of the country that that person lives in to represent them on the chart. And it's a bit of a complex chart. It's not that bad. It's got about 150 nodes on it. And you can see some patterns even at this level of detail. So for example, this group here in the lower left seems to be mostly Malaysians, and here the item I'm selecting is the individual that's responsible for communicating with the rest of the network. But perhaps we want to take a look at this data not at an individual data element level, but at a more geopolitical level. So KeyLines has what we call the combination ability, which is to take a step back and say anything that shares a common property, don't show all of the detail, just show that as a sort of super node or a combined node. So we call it combinations. And in this case, we've combined everybody that lives in a country and just shown a country icon to represent them. So, and we've sized the icon and used the glyph on the icon to showcase the number of constituents inside of it. 70 in Afghanistan, 21 in Germany, 24 in Malaysia, for example. And the other thing we've done here is taken that link width and used it to represent the strength of the connection between those countries, which in this case means the number of intercepted communications between individuals in those countries. So what that tells you, what you can see here, is that there's a very strong connection between Afghanistan and Malaysia, and a much weaker one between, for example, Afghanistan and Saudi Arabia, even though there are more total individuals in Saudi Arabia in this data. And this also allows you to present a lot more data to your end user than you're actually trying to render on the screen at once, and allow them to drill down into the categories that are of interest to them. So for example, if I were an analyst who's focused on Turkey, I can uncombine Turkey, leave the other countries in their groups, and see how the individuals from Turkey are connected to the other countries on the globe. And that can be a very powerful way of allowing your users to do that sort of drill down and focus only on the area that they're interested in working on. So that about wraps it up for me. What I'm going to leave you with here is just a little bit of some playing around that we've done with Twitter and with visualizing relationships in Twitter. So what we're looking at now is a connected set of all of the individuals who talk about poker on Twitter. And we've used their actual handle or their actual avatar to represent them on the chart. But we have a lot of people, and everybody in the poker world, it seems, talks to everyone else. So it's kind of a little bit of a messy graph that we're looking at right now. But what I'm going to do is allow some of that filtering capability, some of that combination capability, and then utilize some of the visual parameters to try to make sense of what we're looking at in this data. So I've allowed the filter to be based on any one of a number of different parameters, including some that we calculate algorithmically on the data itself. So things like betweenness. But what we're going to use now is tweet frequency. So let's say we're interested not necessarily in those people who issue 1 or 2 tweets a month, but only those that have more frequent tweets. So now that I've selected that in the box, I move the slider up. As I move the slider up, you can see items disappearing off the chart. I'm filtering out those items I don't care about and focusing only on the heavier tweeters. And now I can use the various layouts to help organize that data and inspect the connections between them. So this is useful, but now let's also say perhaps we want to use the size of the icon to help us indicate who we really may be interested in focusing on. So for example, now let's take the number of self-mentions as our sizing parameter, number of times that somebody mentions themselves on Twitter. And you can see that the large icons that stand out are the people who do that a lot. And so we may want to focus, for example, on Area Poker. So this is a very nice way of taking the data that we're looking at, allowing the user some flexibility in how to drill down and focus on it, allow them the capability to run various layout algorithms, various filtering algorithms, various sizing algorithms, things like that on the data to get the result that they're interested in getting. So what I'm going to end with here is just some dangers. And many of these are taken care of for you for Neo4j. So things like uniqueness, that's handled because each node has a unique node identifier in Neo4j. But you do have to be careful that you're using that correctly so that you don't get duplicate nodes on your chart. You aren't assigning some parameter that can have multiple instances as a node identifier in keylines, or else you'll get combinations that you didn't intend to get. I talked a little bit already about store rigidity, but don't be forced into presenting to your end users the way that you're storing your data in Neo4j. They may think of it differently, and you may want to present it differently. Overwhelming the user with data, I talked about that already because presenting more than a couple hundred nodes at a single time to the end user, even though KeyLines handles that quite well, can just prevent them from gaining any realistic or useful insight. And then the bottom one there is the one I fall for all the time, which is trying to be too clever. So taking too many visual parameters and assigning them to your, or too many data parameters, assigning them to your visual parameters, the user loses the sense of what they're looking at. So the cardinal sin, I think, is something that I used to do and refuse to do anymore and refuse to let anybody else do, which is to assign numeric parameters to different aspects of red, green, and blue in the color spectrum, so that a purple icon has both a high value for R and a high value for B. Nobody is going to understand that or know what they're looking at, and so you actually will gain less insight than not presenting that type of data to your end users at all. Let them query it.